Uh, Now we are officially starting our class. In meanwhile, few more will join. First of all, I welcome you all again. This is our second class, and we will see the things seriously from today. First of all, I would like to ask you that um, whether HYSYS is running on your laptops or not. शाहजहां ने तो मुझे अपनी सिचुएशन बता दी है। बाकी किसी का कोई इशू है तो वो शी कैन टेल। सबके पास चल रहा है, इसका मतलब है किसी का कोई इशू नहीं है। यस काशिफ साहब, आर यू देयर? सॉफ्टवेयर इज रनिंग।
Assalamu alaikum. Yes, it's working. I'm
ओके,
pretty fine. Yes.
ओके, थैंक यू। एंड आई थिंक only issue with the Shahjahan, and he will also get connected with the software soon, as he said. Some issues with its laptop. Anyway, now we have 6 participants have joined and 3 more. Maybe they will join during our lecture. I am now sharing my screen. I have shared lecture plan. I'm showing you the lecture plan on my screen. Hopefully, you all are watching my screen now. Just one, two confirmations. Shahjahan.
Yes, sir.
Okay. So I shared this slide with this PDF document with you. This is read me first or the lecture plan. That what we will do. Actually, this table is very much important for our course. We will go through these, and these are not only things which we will cover. We will cover some more things which are not mentioned in this list, but these are the primary things which we have to cover at any cost. And the concerned module are written one by one. I will share all the modules when their class will come. Okay, so I have targeted because the list is not appropriate in its position. So I reshuffle the things like in the first session, we will go with the thermodynamics tape this, and I have shared first two modules for this. Now there are two ways to do this. One thing is that I straightforward go with the module individual modules, and then during the modules I will share the information regarding each thing which will appear. The second thing that I am very much comfortable that I just go with my own natural styles and cover some basic things first, and then we will go to the module. So I prefer the second strategy that I first introduce few basic things and some important aspects of the HYSYS. Then we will start our modules. Okay. As we have started with the HYSYS. Let me allow one more person. I think. Okay. No. Okay. So let me start with the understanding of the software. As you know that we always go by clicking to the new. Okay, just a minute. Okay, so now you can. Okay, I have some licenses issues. Okay. Now, if this situation will appear in front of you, then you need uh, to start LSM, license, so LMS, sorry, LMS. Okay. Now, I think we are 8 attendees, so 7 participants have joined. Now, what I am doing that I just taking my licenses once again. अभी मैंने एक थोड़ी हरकत की थी 11 बजे मैं थोड़ा काम कर रहा था तो मैंने एक थोड़ा मसला किया था ये थोड़ा टाइम लेता है अ, ये क्योंकि मेरे ख्याल में 3-4 मिनट या 5 मिनट या उससे भी ज़्यादा ले लेता है कुछ हज़ार सॉफ्ट ये लाइसेंस जो है ना वो पिकअप करवाता है तो मैंने थोड़ा मेरे साथ चल रहा था सॉफ्टवेयर लेकिन फिर मैंने इसको थोड़ा दूसरा एक सॉफ्टवेयर इंस्टॉल करने की कोशिश की थी तो उसके साथ ये कभी कभी क्या होता है कि आप दूसरे सॉफ्टवेयर इंस्टॉल करते हैं तो आपका जो सर्वर है जो उसकी सेटिंग्स थी वो थोड़ी आगे पीछे हो जाती हैं एनीवे ये ये चलेगा इसको हम बीच में इंटरप्ट भी कर सकते हैं बाद में और फिर ये लाइसेंस पिकअप हो जाएंगे if you if anyone want to share something or discuss we have 4 to 5 minutes जब तक ये सॉफ्टवेयर जो है ना वो ओके हो जाए लाइसेंस के हवाले से Okay, I want to give you one overview of regarding the thermodynamics. Uh, you know that in thermodynamics we have three things are very much important. One are called the state variables. We can say that temperature and pressure are the state variable of any substance or material. When you fix the pressure and temperature, then its a volume and its phase is accordingly fixed. So basically, the PVT behavior is very much important, and this is wholly solely thing which we as a chemical engineer learn in thermodynamics. Because in mechanical engineering thermodynamics and in chemical engineering thermodynamics, this is the only difference. In mechanical engineering thermodynamics, they want to see how this PVT will act as a work or converted into work done. But we chemical engineers basically want to see that at which pressure and temperature, what is the state of the matter. And in each operation, we usually changes the states of the matter so that the appropriate work would be done. Like in distillation, um, we have two mixtures, we have two substances are homogeneously mixed in a liquid state. Now we know that at a certain temperature and its relevant pressure, one substance could be converted into a second phase, that is a vapor phase, and this will give a separation, mechanical separation, like vapor and liquid. So we try to achieve that phase via changes its pressure and temperature. So the thermodynamics game is basically the game of temperature pressure. So for any material streams convergence, you need to define the materials by any two variables from state variables like pressure, temperature, or vapor phase friction, and definitely total amount of material in terms of mass flow rate or molar flow rate or volumetric flow rate. And definitely, the third important thing is that you need to define its composition. Even no matter we have only one substance selected, for example, water, you need to define that it's 100%, its composition is 100%. So this is important. Now we can close the program, and I will try to start the HYSYS. I hope few initial licenses were hooked up, so the software will work. If this will not work, then I need to restart my computer. So we will join meeting once again. Okay, now it's okay. So thermodynamics is very much important, and without thermodynamics understanding, we cannot become good chemical engineers, even become good in HYSYS as well. So as you say that we have a component, so I want to select from some components like water, like methane, and I am interested to select some fluid packages. Hopefully, you have seen the videos. If you were not available or someone not available in the lecture one, we have already given the some basic introduction about this graphic user interface that how we enter in the HYSYS. We need to define at least components, one component in the component list and the fluid package, which is backbone of the software. Then we can enter in the simulation environment. Here, this is our simulation environment. Now, unit operations and streams, we have discussed these things in very short briefings in last lecture. Now, today we will see something in material stream or streams understanding. Uh, when you double click on the stream, then you need to give some information to the software that um, uh, which are the basic things or basic properties. On the basis of that, the information HYSYS will calculate the other variables and converge the stream. You can see that on the left side and under worksheet tab, we are seeing that condition and composition. So we need to define some conditions and we need to define this composition is very much mandatory. In conditions, one parameter is related with the amount of matter you are inserting. For example, in the form of molar flow, mass flow, or some volumetric flow, other things. So I can give any variable in this regard and two variables from the state variables. So pressure, temperature, or vapor phase fraction. You can give any two at a time. For example, usually people give pressure and temperature, which are the state variables, and then you need to define the composition. For example, you say that this is 50-50 percentage of matter. Now, when you come here in the composition, you can see that by default the composition basis is selected as a mole fraction, so zero point 0.5 and zero point 0.5. I hope you understand fraction means in the total of one, and this is not the percentage. So percentage is 50-50, but fraction 0.5, 0.5. But these are the mole fraction. But you can change the basis of the calculations like mass fractions, like mole flows, like mass flows, like what liquid volume flows. You can select anyone. And one thing is mandatory that if you have multiple species like I have, and the total of the mole fraction is not one, and then if you click on the OK, then it will calculate the error and apply the weighted average error to all the respective components. For example, I am saying that I have inserted 0.45 and 0.45 instead of 0.5, 0.5. So total is zero point 0.9. Now 0.1 error is there. When I click on OK, and you will notice that 0.5, 0.5 mole fractions automatically set because why this had happened because that the HYSYS will calculate the error and apply the respective fraction of the error to all the species. So because I have given the same amount, 0.45, 0.45 to both the species, so the software have given equal amount of the error to both. But for example, what happened if I say the water is zero point 0.2 and this is 0.78. Now again, 0.02 error is there. Now again I click OK. So now you will notice that 0.204 is added, 41, 41, and 0.79 59 will have added. More error ratio is added in the methane because methane percentage given was higher than the water. So respective error or a fraction of the error, we call it a weighted average, will apply it for the error calculated. So this is very much important sometime in oil and gas sector because Kashif Saab and me were in SNGPL, and this thing was very much important for the gas measurement that our GC calculates how much C6 plus component, and then it's overall making it 100% calculation. So anyway, um, now you see that when I have given the composition and conditions, these three conditions, then the stream is converged. If you see the color of the stream is now becoming more darker blue, dark blue, rather than in first state, the color was not as appropriate. Anyway, now one more thing which need to be understood that I'm making it more large if you can see in a more better way. Okay, now I have given temperature, pressure, and mass flow rate. So you notice that these variables are highlighted with the blue text. Now these are our always our independent variables, and we can change these variables. And the black text variables are dependent variables, and they are now based on these variables which we have given by ourselves. So these are the independent variables. ये बात जो इंडिपेंडेंट वेरिएबल की है, ये बात आपने बिल्कुल सही तरीके से समझ लेनी है, क्योंकि बाद में बहुत सारी चीजें ऐसी हैं जो हम करना चाहेंगे लेकिन कर नहीं पाएंगे। हम फॉर एग्जांपल आगे चलकर हमें जो है ना ये कहा जाएगा कि मोलर फ्लो को चेंज करें। तो अब हम मोल फीड के तो मोलर फ्लो को चेंज नहीं कर सकते। अगर हमें मोलर फ्लो को चेंज करवाना है तो वी नीड टू डिफाइन दिस थिंग विद रिस्पेक्ट टू द मोलर फ्लो रादर देन मास फ्लो। Composition is always the first stream composition is always our independent variable, but later, according to the operation, this composition could be changed. Okay. Now, these properties are shown. These are the important properties, but sometimes you need to calculate the properties or you need to define some other things as well. So you go in the properties page and you can see several other properties which could be also important in your later calculations, like mass density, like enthalpy, like heat capacity, HHV, CO2 loading. Few properties are written, but their values are empty, like CO2 loading, because the stream has no any CO2 or things like that. So it has nothing with this property. So empty value means irrelevant properties in this context. Anyway, if your appropriate property is still not visible in this list, then you can add the properties by clicking this add new correlation. These are not direct properties, but actually these are the correlations and calculated on the basis of some calculations. So when you click on these correlations, you can see there are several correlations. For example, if I need to a GC report, a gas chromatography report, C6 plus on the basis of C6 plus assumption, C12 plus, and so many other standards of a GC are available here. You can, if you have a gas composition, uh, and you just click and it will calculate and give you the appropriate results. For example, in petroleum or in a gas, you can calculate the HHV HC dew point, which was not available in there, Wobbe index. So, so many correlations, so many properties can be added in this list and visible. Then they will be visible. So this is all about material stream. We will come back again here for the dynamics when we will start dynamics. But at least you understand its basic things. Okay. So once a stream is converted, then you can add any number of operations. Sometime people are more interested to start with the unit operations like The same work could be done. For example, if I want to uh, do some heat exchanger heater analysis. So what I do, I can create my own streams. For example, if I have one stream which is named is 22 and 33 is the outside stream and Q is its energy. So people sometimes people also simulate the processes like this. They first insert any unit operation, then their streams are defined with these boxes, and then they go in the worksheet tab, and then they put all information of the temperature, pressure, and the properties and composition from their worksheet tab of the unit operation. So both mechanism are there. You first create your streams and then unit operation. It's up to you, or you just drag and drop your required unit operations and then create the streams from there. Anyway, so now this converge stream can be inserted in any unit operation. Like for example, if this is our stream, which is a mixture of uh, methane and water. And at this temperature and pressure, it has some vapor phase fractions are there. So, for example, if I want to separate out the liquid portion and the vapor portion, so I need to insert some separator, simple separator. This is called flash separator, and you just insert the available stream, feed stream. So on the back end, you can see when you select any stream in the inlet portion, that stream is automatically connected with this operation. Now I haven't defined or created any outlet stream, so I can define it from this. For example, I said this is vapor out, and this is liquid out. So this unit operation only needs these connections, uh, uh, only these material stream connections, and no need of any other parameter specifically for the time being. Otherwise, these parameters are important for the dynamics tapes, but for only calculation of or only separation of the phases, nothing more needed. Now, one thing is important to mention here that you are watching one optional energy stream here. If you give some name of any stream, right? For example, if I say Q and then enter. Now, because I have given some stream, means this flash tank also have some energy circulations. Maybe it is a positive energy or negative energy, like hot water jacketed uh, vessel or cold water jacketed vessel. So cold water means you are taking out the energy from the system, and hot water means you are giving the energy to the system. No matter it's positive or negative, but if you created this in a stream, now the things will unconverge, and you need to define its parameter in the form of energy. Now you can define in several ways. For example, if I have given this energy, I can put some heat flow. If I have given positive, it means it is a hot 20 kilojoule per hour, 200 kilojoule per hour are being inserted in the system. So optional streams are those streams which if you define, then you have to define it completely. Otherwise, if you have not defined, then the system is uh, uh, calculated accordingly without those streams. Anyway, now what happened? Because the inlet stream one, which is named as one, contains the composition of H2 and methane, almost 20% and 80% of water and methane respectively. So they will be separated out. Now 100% vapor will be go with the vapor stream. Its composition is almost methane 96%, but because methane at some temperature and pressure could carry the moisture now, so it has 3% moisture, 3 molar percent. So similarly, in liquid, mostly the water is going with the liquid stream at the same temperature and pressure. Remember, we haven't given any delta P to the system in this unit operation. Like inlet vapor outlet, we do not have given any delta P in either phases. So we are getting at the same pressure. And this is a flash tank. It has nothing to do with the drop of temperature or gain of the temperature. Instead, if you have given this energy. So this is how HYSYS works. You need to define one stream, and then you start building your process and start converging these unit operations one by one. So if you have any question, then you can ask. Then otherwise, we will move towards our first thermodynamic module. Yes, anyone?
Look, hello.
Yes, yes, yes.
Uh, can you explain why did we choose flash here? Because why didn't choose any other type of separator, and why the flash? And what kind of flash is it? Is it a scrubber or what? What is it?
Uh, yes. Uh, Now, sometime the people are very much what you say. What I can say, people are very much professional, and they are watching the things like they watch the things in the processes. Now, this box or all the boxes are actually prototypes or portraying some mathematical things in on their background rather than they are actual the things. Now, what is the function of this flash tank? This flash tank is just separating the vapor phase and liquid phase, which is available in this stream. You can say that if in industries if there is some stream which has some vapor streams vapors in the closed pipes, so if we open it in an open atmosphere, so vapors will go upside definitely, and the liquid will go down. So this is just a replica of that phenomena. This is the flash tank. This is not what you call distillation column, because columns are upcoming in upcoming lectures. We have separators. These are some advanced separators like columns, absorption columns. But this is a simple thing. We need to separate out flashes sometime in our operations. And one more thing. For example, if I want to install a pump here, for example, my objective is to boost the pressure of this stream. Now, this stream is not 100% liquid, either 100% liquid nor vapor. So, if I install pump or even compressor, both the operations give me a little minute error. Though the calculation will perform, but the error would be there. So, in those situations, we need to separate out the flashes or the phases, and now we can take their phases at appropriate level. So, hope the question, this is the answer of the question.
So that means it just could be a knockout vessel.
Knockout vessel. It is just portraying the knockout vessels phenomena, and nothing more. And the similar kind of thing is a three-phase separator. We have also a three-phase separator here, uh, which now you can see this is a three-phase separator. Now, in this flash, only two phases are being separated out. This three-phase separator, very famous in the oil and gas sector. You can see in any inlet stream is actually separated in a three phases. Liquid means light liquid or low density liquid, high density liquid, and vapor stream. Because low density and high density liquids usually have immiscibilities, not miscibles like oil and water. So eventually you can have the three separations, and in this tank or in this thing we have only two. We will cover one by one all the things, or at least the important ones, and once you get the philosophy of the HYSYS, that how these things are being converged, so you can do by yourself. Okay, now only the need is just to grab the things or watching their simple things. Now in these all almost 30% or 40% unit operation are very much simple. Like this flash tank, you have done nothing, only just connecting a connection of the stream. For example, instead of this, I need I am interested to okay. I am interested to have uh, I am increasing the temperature. For example, I am saying this is 150. Now, one at 150 degrees centigrade, this composition stream has a 100% vapor phase. Now, for example, if I want to increase its temperature from 150 to some higher temperature, let's say 200 degrees centigrade. So I need to install the heater. So I just take the heater from the list and fulfill the requirement of their inlets and outlets. For example, one is our inlet, and I'm saying two is my outlet, and I just inserted energy Q, and now basic requirements of the unit operation is fulfilled. So you see in unit operations, the ribbon is converted first in from red to yellow. And now you need to define some parameters. In previous operation, nothing was required after the primary connection setup. But here you need to define what. First thing is that in any heater or any operation, mostly delta P is very much important. You at least give some value of the data. Usually for the sake of understanding or for the sake of calculations, we provide delta P 0. Now this is regarding delta P. Now we have to define it one more thing, that whether you know the rating of the heater in the form of kilowatt, megawatt, or you need to have you have the information about the how much temperature you need to raise. For example, I said that the inlet stream is at 150 degrees centigrade. I want to increase its temperature from 150. I just want to give here the 200 degrees centigrade. So the rest of the things will be calculated by the appropriate mathematical equation on the background, and you see that its duty, heater's duty, is automatically calculated. Now this the same operation could be converged via three things. Either you provide duty or direct delta T, or as I have done, the temperature of the outlet, because heater's function is to raise the temperature. So I have given the new temperature level, and the things were calculated accordingly. Okay. Now sometime I'm not very much um, uh, uh, I want to see always some temperature and pressure information. So in flow sheets, by default, the names are ticked here. In the flow sheet, names are ticked here in the stream label. I need to tick the temperature and pressure. So it will give me some information regarding this. Star values are showing that these are the independent variables. 150 value was given by user or by myself. 101 kilopascal also was given by myself. 200 degree centigrade of this stream also given. And this pressure was calculated on the basis of our information given, that inlet pressure is this one and delta T is 0. So same pressure at outlet. Anyway, so this
So
is now
that
converged.
means
Sorry.
so that means this much energy you have to give to this heat exchanger to produce this much delta T. Is that right?
Yes. Now,
So duty
in
is
my
that energy.
duty is energy. Power or duty is energy. From this, it says that you need to provide 0.3512 kilowatt to the stream of 10 kilogram per hour. This is the total mass flow rate is 10 kilogram per hour. Uh, and you have to achieve. You can get your desired temperature 200. Now here I have a question that how you actually calculate if I need to calculate how much energy I have to provide if I give you the mass flow rate, that is 10 kilogram per hour. If I need, I can give you the temperature, inlet temperature and outlet temperature. How you calculate usually? Anyone?
So throw sensible heat and latent heat.
You throw sensible heat Q is equal to MC delta T. Okay, so if you know the specific heat of this stream, now specific heat of this stream can be seen from the properties Cp. Specific heat of the stream is specific heat is okay. Specific heat, molar specific heat is 40.43. 40.43 kilojoule per kilogram mole per degree centigrade. If this information is given to you, then can you calculate the thing that the temperature the energy requirement?
Yes, sir, we can do this. Through latent heat, through sensible heat, we can do this.
Okay, but when you try to calculate, you will find that exactly this power will not be calculated. Any reason? अभी आप अगर करके देखें, अगर आप इस सिस्टम का मैं आपको मोलर फ्लो भी बता देता हूँ। मोलर फ्लो इस वक्त जो मुझे नज़र आ रहा है 1.221 into 10⁻²। सॉरी एक ओके, मेरे पास जो नज़र आ रहा है मोलर फ्लो, सॉरी ये तो CMM CFD में आई कैन चेंज द यूनिट्स। अभी मैंने यूनिट्स की बात आपको नहीं बताई, ये भी मैं आपको अभी बताने वाला हूँ, लेकिन अभी मैं फिलहाल इसको जल्दी से मोलर फ्लो को अपने डिजायर्ड यूनिट में चेंज कर रहा हूँ। मोलर मोलर फ्लो MMCFD नहीं, बल्कि हम किलोग्राम पर मोल पर आवर के हिसाब से देखना चाहते हैं, जो उसका डिफॉल्ट यूनिट होता है। ओके, अभी जो मेरे पास मोलर फ्लो है किलोग्राम मोल पर आवर, वो है 0.6081। अगर आप लिखना चाहें, मिसाल तौर मैं आपके लिए कैलकुलेशन कर रहा हूँ, मैं एक आपको बात जो चीज़ समझाने की कोशिश करूंगा, वो बड़ी इंपॉर्टेंट है। हमें सबको पता है, हम सब काफ़ी एजुकेटेड हैं, इन इस सब प्रोफेशनल्स हैं या स्टूडेंट भी हैं, तो काफ़ी अच्छे हैं। मैं आपको एक सिंपल सी बात बता रहा हूँ, और आई होप आई कुड प्रूव। ये मैंने क्लास में भी समझाया था स्टूडेंट्स को रिसेंटली। मैं इधर लिख रहा हूँ कि मेरे पास जो मोलर फ्लो है वो नज़र आ रहा है 0.6081 किलोग्राम मोल पर आवर। ओके, और टेम्परेचर जो है, टेम्परेचर इन मैं इसको T1 कह रहा हूँ, वो है 150 C। TO आउटलेट टेम्परेचर हमने 200 डिग्री सी किया हुआ है। मोलर फ्लो हमें मिल गया, ठीक है ना। MC डेल्टा T इसकी स्पेसिफिक हीट जो है, स्पेसिफिक हीट जो इस सब्सटेंस की या स्ट्रीम की है, वो भी मैं आपको बता रहा हूँ 40.43। 40 CP इज इक्वल टू 40.43 किलोग्राम मोल पर सॉरी किलो जूल पर किलोग्राम मोल इंटू C। स्पेसिफिक हीट किलो जूल पर किलो जूल पर किलोग्राम इंटू C। ओके, फार्मूला इज Q इज इक्वल टू MC डेल्टा T। फिलहाल हम सैम्बल्स को नहीं यूज कर रहे, सो Q इज इक्वल टू M यहाँ पर मास फ्लो रेट की बजाय हम मोलर फ्लो लिखेंगे, बिकॉज वी हैव C इज इन अ मोलर फॉर्म। सो 0.6081 times C is 40.43 times delta T is 200 minus 150. So if I calculate this, 0.6081 into 0.4043, sorry, 40.43 into 50. 200 में से 150 गए तो 50. So it has a 1229. Answer is 1229.27 किलोजूल, क्योंकि किलोग्राम मोल से कट गया और C पर C से कट गया. Now if I see the calculated amount, now calculated amount is किलोग्राम जूल पर आवर. ठीक है, वो हमने पर आवर ही लगाया 1264. 12 जो ये तो हमने कैलकुलेट किया और 1264 किलो जूल आ रहा है. This is the answer by HYSYS, and this is simple calculations. Now, who can tell me what is the issue? Yes.
So maybe there is some ideal issue that no heat loss is included.
Sorry, no.
Heat loss.
No, I don't think so. Anyone else want to? The thing is that this is CP or specific heat which we are watching, because everyone know is that some properties are very much sensitive to the temperature dependent properties. Now this specific heat, which is showing 40.43, is at 150 degrees centigrade. If I say 151, if I raise only 1 degree centigrade, then you will notice that specific heat is a little bit varied, 40.48 instead of 40.43. Now it is 40.48. So in each temperature rise 1 unit, the CP is changing. So HYSYS is calculating, it is not calculating directly by this just multiplication, but in literature, instead of this formula Q is equal to MC delta T, the real formula is what? अगर हम इसके रियल फार्मूला को हम पहचानते हैं तो हम इक्वेशन एडिटर का मैं सहारा लूंगा लिखने के लिए. Q इज इक्वल टू M इंटू डेल्टा T इंटू डेल्टा T या dt. ओके, फिलहाल हम इसको डेल्टा T कहते हैं. rather than delta T we have, हम इसको लिखते हैं M और इसके बाद हम देते हैं इंटीग्रेटिंग from temperature 1 T1 to T2 Cp dt, d for temperature because this is a function. So basically we have to integrate the Cp values from all the temperature intervals from T1 to T2, and then we multiply with the mass or molar flow rate according to the Cp unit. So this is the difference that why we say that HYSYS is very much important or calculate more accurately as compared to our simple calculations, because you don't know that in simple calculations we have some errors, error of ideality or error of what you call it, not averaging or assuming some thing, like we have assumed that Cp is constant throughout the temperature. Similarly, density is varying, K is varying, several things are varying. So we must understand these things prior to have in our routine calculation. Okay, ये जो calculations हैं,
Sorry, come again.
जी.
With this integration formula, I come again.
Okay, I said that we have a formula. Usually, we use Q is equal to mc delta T formula for the sensible heat. But in real, if you see that C is temperature dependent quantity. So this C is sometime a polynomial function of the temperatures, and we have to integrate this Cp from temperature 1 to temperature 2, which is nothing but our delta T. What I want to convince you that when we calculate by assuming something as constant with respect to temperature or some other things, we calculated 1229.27. Though the calculation has no any error, as we all are very much fully convinced with this calculations. But HYSYS is not giving us the true answer or same answer, but HYSYS is giving 1264. So I want to give, to have explanation that actually in HYSYS, robust calculations are on the background with minute understanding of these things as well. So when something is not convincing to you in the calculation, you must understand that why these things. हम क्या करते हैं, कभी कभी क्या होता है कि हम कोई कैलकुलेट कर रहे होते हैं, हमारे जहन में होता है कि ये आएगा जवाब, लेकिन वो नहीं आता हाइसिस में। तो हमें उसके पीछे जाना होता है। जब हम उसके पीछे जाते हैं तो हमें बहुत सारी इंफॉर्मेशन मिल जाती है, अगर हम उसी तरीके से पीछे जाएं जैसे उसका जाने का हक है। Anyway, now I am coming towards our first module. अब हम क्या करते हैं, इस मैंने जो अभी 2 मॉड्यूल शेयर किए, इस एक लेक्चर का प्लान था और मैंने थर्मो के पहले 2 मॉड्यूल फ्लैश मॉडल शेयर किया। ये बहुत फंडामेंटल मॉडल है और इस मॉडल के करने का जो मकसद है वो आपको बेसिकली 3 चीज़ें जो जो इनपुट्स है ना स्ट्रीम्स के, वो समझाना आपका हमारा मकसद है कि हम हाइसिस में जो है ना वो कैसे यूज़ करते हैं। Learn how to model a flash separator and examine different thermodynamic models to see how they compare. Flash models actually समझने हैं। हमारे पास 5 कंडीशंस हैं या 5 फ्लैश मॉडल्स हैं। एक है पीवी फ्लैश, प्रेशर वॉल्यूम फ्लैश, फिर टीपी फ्लैश, फिर टीवी फ्लैश, फिर पी क्यू फ्लैश, फिर टी क्यू फ्लैश। ये हमारे पास 5 कंडीशंस हैं जो हम इस ट्यूटोरियल में जो है ना वो यूज करेंगे। इस प्रॉब्लम में हमने करना क्या है, हमने करना ये कि वी वांट टू इन्वेस्टिगेट द वेपर लिक्विड सेपरेशन एट डिफरेंट प्रेशर्स, टेम्परेचर्स एंड कंपोजिशंस। Assuming you have a feed with an equimolar binary mixture of ethanol and benzene. When we say equimolar binary mixture का मतलब है कि इसमें 2 ही चीजें हैं, इथेनॉल एंड बेंजीन। इक्विमोलर का मतलब है कि जितने मोल इथेन के हैं उतने ही मोल बेंजीन के हैं, तो इसकी मोल फ्रैक्शन क्या रहेगी, 50-50%। मतलब 0.5 मोल फ्रैक्शन इसकी रहेगी, 0.5 मोल फ्रैक्शन इसकी रहेगी। भले मोल्स कितने भी हो, मोल फ्रैक्शन उतनी ही रहेगी, 0.5 क्योंकि इक्विमोलर है। 3 मोल इसके, 3 मोल इसके, तो फ्रैक्शन सेम रहेगी, 0.5। और उसका प्रेशर बता दिया गया एट 1 बार एंड 25 डिग्री सी। एग्जामिन फॉलोइंग फ्लैश कंडीशन यूजिंग हीटर ब्लॉक इन एस्पेनाइसिस। एक हम हीटर ब्लॉक का मतलब है कि ये ब्लॉक कह रहा है जो हम ऑपरेशन कहते हैं। अभी हमने हीटर ब्लॉक ही यूज किया था। यूज वेपर लिक्विड एज द वैलिड फेज इन द कंप्यूटेशन। ठीक है ना, हमारे पास वैसे भी लिक्विड वेपर ही होता है, वैलिड फेज होता है। अब इसमें हमने ये सारा ट्यूटोरियल टाइप बना हुआ है। मैं आपको क्विक इसके ग्लांस देके फिर आपको मौका दूंगा कि आप मेरे साथ करें अपने अपने लैपटॉप पर जिनके पास हाइसिस है, और फिर हम जवाब को कंपेयर करेंगे। हमारे पास हाइसिस वर्जन 11 है, ये वर्जन 8 के हैं। बहरहाल ऑलमोस्ट सिमिलर ग्राफिक यूजर इंटरफेस आपको नजर आएगा। हम क्या करेंगे कि कंपोनेंट लिस्ट में से इथेन, इथेनॉल और बेंजीन ये 2 लेंगे। जैसे इसने दिखाया कि कंपोनेंट लिस्ट में आपने इथेनॉल और बेंजीन लिया, और फ्लूइड पैकेज में ये स्पेसिफिकली एनआरटीएल को पिक करवाने के लिए कहा रहा है। ठीक है, आप क्योंकि हमने इस मॉड्यूल को ही एज इट इज करना है, तो आप उसी फ्लूइड पैकेज को पिक करें जो वो कह रहा है। गो टू द सिमुलेशन। अब सिमुलेशन में करने के बाद वो कह रहा है कि एक हीटर ब्लॉक रखो। इस हीटर ब्लॉक को आप रखेंगे और इसके बाद जो है वो उसको डबल क्लिक करके आप सारी स्ट्रीम्स इसी हीटर ब्लॉक के डिजाइन टैब से या कनेक्शन टैब से ही बनाएंगे। जैसे इनलेट पर फीड स्ट्रीम बनाएंगे, आउटलेट पर आउट, और एनर्जी में क्यू लिखेंगे। ये जब बनाने के बाद आप पैरामीटर्स में जो है ना वो स्पेसिफाई कंडीशन फीड, गो टू द वर्कशीट टैब। अब आप वर्कशीट पर आ जाएं और यहाँ पर आप क्या करें कि टेम्प जो फीड स्ट्रीम है उसका तो टेम्परेचर फिक्स है 25, प्रेशर 1 बार या 100 किलो पास्कल, और मोलर फ्लो 1 किलोग्राम मोल हो गया, और मोल फ्रैक्शन उसकी 0.5 कंपोजिशन में दे दी हमने। ठीक है, अब हम क्या करते हैं, ये फीड स्ट्रीम तो फिक्स है जो कि इसने बता दी। अब हम आउटलेट पर डिफरेंट डिफरेंट काम करेंगे। पहला आउटलेट पर कंडीशन 1 में क्या कह रहे हैं कि हम वेपर फेज फ्रैक्शन को 0.5 रख रहे हैं और प्रेशर को 100 रख रहे हैं। इससे हो क्या रहा है, इसमें हमें मिल क्या रहा है, हमें हमें जो है ना वो 67.03 टेम्परेचर मिल रहा है। ये टेम्परेचर वो टेम्परेचर है जिस पर हमारी जो ये स्ट्रीम है वो 50% वेपर में कन्वर्ट होगी, बाकी 50% इस वक्त जो है फीड स्ट्रीम जो है वो है लिक्विड फॉर्म में। हमने इसको 25 डिग्री सेंटीग्रेड कितना गर्म करें कि ये 50% वेपर फॉर्म में आ जाए। तो ये हाइसिस बता रहा है कि अगर आप उस कंपोज़िशन को 50% फिक्स कर लेते हैं, तो ये आपकी 2 चीज़ें कैलकुलेट कर लेगा। टेम्परेचर बता देगा कि कौन-सा टेम्परेचर उस फ्लैश के लिए चाहिए, और क्यू भी कैलकुलेट कर लेगा कि इस इतने फ्लैश के लिए आपको टेम्प क्यू कितना चाहिए। तो इसके बाद अब ये कह रहा है कि अब आप जो है ना वो कंडीशन 2 रखेंगे। अब आप फिर से इसको डिलीट कर देंगे एक कोई वेरिएबल ताकि ये एम्प्टी हो जाए, और फिर अभी मैं ये आपके सामने करूँगा अभी सही। वेपर फ्रैक्शन अब हम क्या कर रहे हैं कि अब इंस्टेड ऑफ गिविंग द 50% फ्लैश वेपर फेज, हम जो कैलकुलेट हुआ था ना पिछले कंडीशन में 67.03, वो टेम्परेचर और प्रेशर सेम दे दिया। तो ये देखेंगे कि वेपर फिर भी तकरीबन 0.5 के करीब आएगा जो कि हमने पहले दे दिया था, और ये टेम्परेचर आउटपुट किया था, और क्यू इस तरह कंडीशन 3 में हम 0.5 और टेम्परेचर दे रहे हैं तो प्रेशर 1 निकलेगा और क्यू निकलेगा। कंडीशन 4 में हम जो है ना वो प्रेशर और क्यू दे रहे हैं तो वो दोनों चीज़ें कैलकुलेट कर रहा है, और कंडीशन 5 में भी हम जो है ना वो टेम्परेचर और क्यू दे रहे हैं। इवेंचुअली आपको ये कंक्लूजन की एक टेबल बनाकर दिखा रहा है जिसमें आपको ऑरेंज कलर या ऑरेंज ही मुझे लग रहा है, ऑरेंज कलर के जो बॉक्सेस हैं वो स्पेसिफाइड वैल्यूज हैं, और जो येलो कलर के हल्के येलो कलर के बॉक्सेस हैं वो कैलकुलेट। तो जब प्रेशर पीवी फ्लैश का मतलब है कि आपने प्रेशर बताया और वेपर फेज बताया 50%, तो उसने टेम्परेचर और क्यू खुद ही कैलकुलेट कर लिया। फिर आपने टेम्परेचर और प्रेशर बताया तो वेपर फेज और क्यू कैलकुलेट करिए। अगर आप गौर से देखें तो सब जगहों पर वैल्यू सेम ही है तकरीबन, कहीं-कहीं पॉइंटों में फ़र्क है, अदरवाइज़ ऑलमोस्ट वैल्यू सेम ही है, लेकिन डिफरेंट तरीकों से आप यही चीज़ें कैलकुलेट करवा सकते हो। डिफरेंट चीज़ों का मतलब ये है कि आपने 2 चीज़ें देनी है, बाकी 2 चीज़ें वो खुद ही कैलकुलेट करेगा। इन 4 सेट की कॉम्बिनेशन बनेगी कि भई आप ये 2 दे दो, या पहले 2 दे दो, या टेम्परेचर और वेपर फेज दे दो, या प्रेशर और क्यू दे दो, या टेम्परेचर और क्यू दे दो। ठीक है? ये हम करेंगे, और इसके करने से हमें कोई ख़ास फ़ायदा नहीं मिलेगा। एक तो जो लोग हाइसिस को आज तक उन्होंने यूज़ नहीं किया, वो भी बेटर महसूस करेंगे, और जो हाइसिस को एब्रप्टली यूज़ करते हैं तो उनके लिए थोड़ी ये एक प्रैक्टिस हो जाएगी कि जो हम कह रहे हैं कि कौन-सी चीज़ें रिक्वायर्ड होती हैं मटेरियल स्ट्रीम को कन्वर्ज करने के लिए, वो ये हैं। ठीक है? एंड नाउ आई एम डूइंग दिस, और आप लोगों को भी मैं दावत दूँगा कि आप अपने लैपटॉप्स पर ये ज़रूर करें, और फिर देखें कि अगर हमारे पास जवाब सेम आ रहा है या नहीं आ रहा। इफ यू हैव एनी क्वेश्चन देन यू कैन आस्क एट एनी टाइम। मैं अभी इसमें से अब मैंने तो ये एक एग्जांपल से खोला हुआ था, तो मैं इसको जो है ना रिमूव करके मटेरियल्स मैं इसमें दे रहा हूँ। कंपोनेंट्स थे बेंजीन, और कंपोनेंट थे इथेनॉल एंड बेंजीन। सो इथेनॉल, you can type its name or formula. यहाँ पर NRTL, क्योंकि इथेनॉल वो कह रहा है कि आपका फ्लूइड पैकेज जो है ना वो कि उसने उठवाया ही वही है, और आप बेंजीन दे दें, बेंजीन। ओके, हमने अपनी चीजों को हमने वो बंद कर ली थी फ्लो शीटिंग। ओके, सो एनीवे, अच्छा ये कभी कभी हमारे जो है ना वो मिसाल तौर टूल पैलेट नहीं बंद हो जाता है या ऑन द बैकग्राउंड हो जाता है, तो आप ऊपर फ्लो शीटिंग में अगर आप देखें ऊपर फ्लो शीट मॉडिफाई में आप मॉडल्स स्ट्रीम्स को डबल क्लिक करेंगे तो आपका ये वापस टूल पैलेट आ जाएगा। ये अवेलेबल होता है ऑन द टॉप मेन्यूज फ्लो शीट मॉडिफाई में पहला पहला लेफ्ट साइड पर मॉडल एंड स्ट्रीम्स। ओके, हमने हीटर ब्लॉक रखा और इधर से ही हमने फीड स्ट्रीम बनाई, फीड और आउट और क्यू स्ट्रीम बनाई, और हमने जो है ना वो डेल्टा पी 0 कर दिया और हमने वर्कशीट में गए डायरेक्ट। यहाँ से भी हम स्ट्रीम्स की इंफॉर्मेशन बता सकते हैं। हमने फीड स्ट्रीम को तो उसी तरह डिफाइन कर लिया जिस तरह इन्होंने पहले डिफाइन किया था। जस्ट सी के उनकी फंडामेंटल वैल्यूज कौन सी हैं, 25 डिग्री सी, किलो पास्कल 100 और 1, तो 25 डिग्री सी 100 किलो पास्कल और किलोग्राम मोल पर 1, ये टोटल मोलर फ्लो 1 है इसका। और कंपोजिशन में आपके 0.5 मोलर फ्रैक्शन है। ओके, अब हम वर्कशीट में ये हमने फीड स्ट्रीम कंप्लीटली डिफाइन कर ली। ओके, अब हम बताएंगे यहाँ से कि इसका टेम्परेचर, अच्छा हमने जो है ना वो डिज़ाइन टैब में जो है ना वो डेल्टा टी दिया था 0, इसको हम डिलीट कर लेते हैं क्योंकि हमारे पास ये टेम्परेचर, ये भी प्रेशर भी हमारे पास आना चाहिए कि कितना है। ओके, जब हम पहला था पीवी, हम प्रेशर बता देते हैं कि 100 किलो पास्कल, और हम वेपर फेज फ्रैक्शन 0.5 बता देते हैं। तो यू विल नोटिस कि एग्जैक्टली वही वैल्यू जो है हमारे पास भी आई है, 67.03 डिग्री सेंटीग्रेड, और क्यू भी हमारे पास कैलकुलेट होते हैं। अच्छा, अब हम इस को वापस करना चाहते हैं, हम अब टेम्परेचर देना चाहते हैं, तो कैसे करेंगे एनीवन? हम अब टेम्परेचर देना चाहते हैं, अब हम इसको दूसरी कंडीशन पर अप्लाई करना चाहते हैं कि हम 67.03 देना चाहते हैं, तो हम कैसे करेंगे? पहले हम इसको अनकन्वर्ज करेंगे। ये आप सब लोग ये ध्यान में रखें कि जब एक दफा कन्वर्ज चीज हो जाती है तो अब हम टेम्परेचर यहाँ से दे नहीं सकते क्योंकि ये डिपेंडेंट हो गया। इफ यू ट्राई टू डू, आप नहीं कर सकेंगे। सबसे पहले आपको इस स्ट्रीम को फिर से अनकन्वर्ज करना होगा। अनकन्वर्ज करना, कोई भी वैल्यू इसकी जो मिसाल और वेपर फेज फ्रैक्शन हमने कैलकुलेट करवाना है बाद में, इसको डिलीट मार लें तो ये एम्प्टी हो जाएगा। वंस इट इज एम्प्टी, अब आपके पास दोबारा टेम्परेचर देने की है 67.03। व्हेन यू एग्जैक्टली पुश दैट टेम्परेचर, तो आप देखेंगे कि अगेन 0.5099 जो बुक में भी है और हमारे वही कैलकुलेशन आ रही है। अगेन मैं इसको ट्राई करना चाहता हूँ। मैं कहता हूँ कि अब मैं जो है वो टेम्परेचर प्रेशर नहीं दे रहा, लेकिन अब मैं 0.5 फिक्स कर रहा हूँ इसको, तो प्रेशर अगेन 100 आ जाएगा। तो ये आपकी मुख्तलिफ कंडीशन बता रहा है जिससे आप इवन क्यू भी बता सकते हैं। आप ये चीज़ ना बताएं, सिर्फ टेम्परेचर बताएं, और वो जो क्यू की वैल्यू है, की वैल्यू एग्जैक्टली जो कैलकुलेट हो रही है, मैं नीचे जाकर देखता हूँ जो बार बार 23.63 मेगा जूल पर आवर। 23, इसका यूनिट देखना पड़ेगा हमें। 23.63 मेगा जूल पर मेगा एम। यू विल नोटिस के अगेन 0.5 आया है पेपर फेस फ्रैक्शन और 100। तो हम ये भी कर सकते हैं कि हम सिर्फ टेम्परेचर बताएं और क्यू बताएं, तो भी ये फ्लैश जो है ना वो खुद ही कैलकुलेट हो जाएगा। तो ये आपका बेसिक टास्क है। इतने बंदे मेरे साथ ये कर रहे हैं अपने अपने लैपटॉप्स में। इफ voluntarily they can tell me.
I'm trying.
Okay. शाहजहां के अलावा तो सब लोग को ट्राई करना चाहिए अगर उनके पास लैपटॉप चल रहा है। क्योंकि अगर हम ये ट्राई नहीं करेंगे तो फिर हम उस तरीके से इस कोर्स का जो है ना वो फ्लेवर नहीं ले सकेंगे। अभी तो ये तो चलो आसान भी है। आई कैन अंडरस्टैंड अगर बहुत सारे आप लोग फ्रीक्वेंट हो या बहुत अच्छे हो आईसीएस पर, लेकिन बहरहाल फिर भी आपको ये चीज़ें करनी चाहिए। ओके, जब तक कोई मुझे जो है ना वो कंफर्म करेगा कि थिंग्स आर ऑन द सेम पेज और उसी तरह चल रही हैं जैसे मैं एक्सपेक्ट कर रहा हूँ। जी काजू साहब।
Still selecting heater.
Are you doing Abdul Rab and engineer MSM or Hassan Bilal?
Yes, sir, I'm trying.
Okay, good. जी MSM का नाम क्या है यार? इंजीनियर MSM। जी बताएं आप। MSM मोहम्मद सलमान।
Sir, I think it's Sultan.
सॉरी,
I think it would be Sultan.
सुल्तान। MSM उन्होंने हाथ रेस किया है, तो अगर अभी तक हाथ रेज है तो इसका मतलब है कि उनको कोई इशू है।
What's the delta P?
डेल्टा पी आपने नहीं देना क्योंकि आप प्रेशर भी तो कैलकुलेट करवा रहे हो ना आउटलेट का।
Delta T?
डेल्टा पी और डेल्टा टी नहीं देने दोनों। आपने तीसरे उसमें आ जाना है। वो उस हीटर ब्लॉक का तीसरा जो है ना वो कह रहा है कि वर्कशीट आपने
Okay.
रेटिंग में नहीं जाना, वर्कशीट में जाना है। डिजाइन से निकलकर वर्कशीट में। अब आप यहाँ पर फीड स्ट्रीम तो कंप्लीट डिफाइन कर लिया आपने। अब आप आउटलेट पर मुख्तलिफ तजुर्बात कर सकते हो।
Sir, what was the flow rate? Can you
Assalamualaikum
please
sir.
give?
जी बताएं।
Hello, Assalamualaikum sir. Sultan here.
वालेकुम सलाम। जी
Yeah, sir. I just put the feed stream.
ओके।
Now I am unable to get the output stream. How can I get the output stream?
ओके। when you see in are you watching screen, my screen?
Yes, yes, I am seeing your screen. Yes, sir.
Okay, when I have a heater block,
Okay.
have you inserted the heater block? So double click the
Yes,
heater
sir.
block. Then you
Okay.
by default you are on design tab. Here one is inlet box and another is outlet box. So
Okay, okay, sir.
you
Okay,
just
okay.
type any name in outlet.
Yes, I receive. Yes, sir. Okay.
जी काजल साहब, done it?
Not yet. Still working on feed, but
Okay.
so how about the out feed?
Uh, when you provide the information of feed in the worksheet tab, so
Mm-hmm.
you need to insert temperature, pressure, and molar flow, and in composition, the composition of 0.5. Then in condition again, now you have a outlet stream as well because you have given outlet stream as well at this place.
Okay, what are our molar flow rate? What was it?
Molar flow rate is 1 kilogram mole per hour.
Okay, so it's just one.
You can give any molar flow rate.
Okay.
Hello, excuse me, sir.
Yes.
It is asking for the delta P. Should I give delta P here?
No, you need to come here because in this particular case, you do not need to give the delta P because you need to calculate what is the delta P by the software.
Okay. So in worksheet,
In worksheet, you will see three streams. Two are material streams. One is the energy stream. Third one.
Phase friction.
So now when you specify this feed stream, then you need to go to the heat exchanger.
Not heat exchanger, heater.
Yeah, heater.
Uh, uh, you need to provide now any two variables. For example, in this particular, I'm now again showing you. You just
Okay.
put
Yeah.
any two variables. For example, zero point 0.5 in vapor and 67.03. So you noticed that pressure and Q automatically calculated.
0.5. 67 is the temperature. Now I just showing empty on pressure.
Any two things here will
Yeah.
converge the whole solution.
Excuse me, sir.
Are you still getting the empty? Okay, now all of you, I have missed one thing to inform you that your one eye should always be on this solver, whether it is in a active mode or on hold mode. If it is on hold mode, then you will not see the instant calculations. So this solver mode should always be in active mode.
It is active,
Okay, now if
but
it is
still
active,
empty. Yeah.
if it is active, and so uh, are you getting these three streams? Means you define the inlet stream, you define the outlet stream, and you define the energy stream name.
Yes.
Okay, now feed stream, you must provide these three informations: temperature, pressure, and molar flow, and composition of feed stream 0.5, 0.5.
Yes.
Okay. Now in outlet, you just provide the vapor as vapor phase 0.5 and any temperature, but for example 67.03. So you will notice the pressure and Q automatically calculate. Not calculated.
That's one thing I couldn't know because this is not happening.
Yeah. Okay. Uh, can you share the snapshot on WhatsApp of
Yes.
this stream particularly
Okay, yeah. Of this stream.
of
Of
this
this
stream?
screen, yeah, yeah. I can
Okay.
just share it. Yeah, just hang on.
Hello, sir.
Yes, yes.
I'm going to change the molar friction 0.5, 0.5, but it's not appear on my screen. Why it's happening?
Okay, I can give one by one you people chance to share your screens. For example, first Kashif Saab, I'm making you as a presenter.
Okay.
Now you just share your screen here.
Yes, sure. Just a minute.
And then I will ask to Rehan and MSM.
Now we're gonna go for sharing the screen.
Top if you see the top leave button के साथ stop
Share. Ah,
enable
yeah.
stop
Share.
share
Okay.
screen.
Okay. There you go.
Okay, it is okay now. Okay, uh, can you
So if
now can you click on the double click on the heater block? Okay. Okay. Now what you have done? You have done one thing additional. You have provided the vapor information to the feed stream as well. You just delete it. Point 0.5 to the feed. Delete it.
okay.
Enter. Okay. And temperature, pressure. Now show me the composition. Okay, one. ठीक है. Okay. Okay. Composition. Go to the composition. Now see, in the feed stream,
Hmm.
no component, zero point 0.5 to each component, zero point 0.5 enter, and in benzene also, no,
Oh no
benzene
no no.
0.5 and zero point 0.5. Okay, okay, zero point 0.5 and zero point 0.5. Okay,
This
now
one is
go in
green now. Yeah.
condition, go in a condition. Yes, this.
Hmm.
Now
Now
see,
this one.
everything is now calculated.
Hmm.
0.5, 67, because
Hmm.
67.03. Just type 67.03 exactly. So you will see the 167.03.
Oh, now it
Okay.
calculates. Yeah. Now that's
Okay.
fine. Yeah. Mhm.
Now I'm just making you again attendee.
Okay. Thank you.
Okay. Now Mr. Rehan, are you there?
Yes, sir, I'm here.
I'm making you. You have some problem?
Yes, sir, I have some problem. Sir, in
Okay.
facial, yes, sir.
May
Can you please?
I am making you the presenter. Now you just share your screen and then we will discuss.
Okay, sir.
Now you can share the screen.
Sir, have you seen?
Uh, Not yet.
No.
Sir, I have click on share content, share screen or tab.
Share screen.
Okay, then I
Share screen. See, my screen is visible on your screens.
yes, sir, I have seen.
Yes, sir.
Uh,
Yes.
on the right side, where I can show you stop sharing, you can see here share screen. And when you click share screen, then multiple options will come. You just click on the first option, share screen.
Sir, I'm click on share screen, then new tab is occur, and on this tab, select a tab
Uh,
to video. Sir, I don't know from where I shared.
शेयर स्क्रीन करें उसके बाद बस आ जाती है स्क्रीन अगर कोई और ऑप्शन तो नहीं आता यूजुअली
Again, I'm going to content, entire screen. Then I select on share, but nothing has happened.
Just
Then you have
share
to
the.
Sir, have you
select
seen?
your screen as well.
Okay, 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 okay. Now you just now we can watching your screen. Okay. Now go to
Sir,
HYSYS. Okay,
sir, I have a problem that I have put the pressure in kPa, but
okay,
it
okay,
it will open on again a bar in bar.
okay, okay. Bar. Okay. Now your pressure setting. Okay, your case is converged, but you facing some problem in the units. Now I'm giving you all regarding one lecture before closing. Today's lecture is regarding unit sets. I think you have no any issue with the case, but only the units.
Yes, sir.
I will share this information after just this.
Okay,
Okay.
sir.
Now MSM. Yes, MSM. Uh, are
Yes,
you
sir,
there?
Sultan here. Yes, sir. Yes.
Sultan.
Yes.
I'm making you present. You have some issues.
Yes, sir.
Okay. Yes. Share your screen.
Yes, sir. Can you see, sir?
Okay. 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 Now we are watching. Okay. Now you have in stream, you are out stream and Q stream.
Yes.
Okay. Now you haven't given the molar flow. Just one click on the in stream. Are you watching in stream? Yeah. Where your empty set is selected, yellow color empty cell. Molar flow of in stream. Yes. There.
Yes.
Yes. One. Press one.
Yes, sir. I give is twice, but
Okay.
it
Okay.
again
Okay.
making zero.
Okay. 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 Good. Now go in the composition tab.
Okay. It's
Okay. Good.
already
Now.
given.
Okay. Now go in condition tab again. Once again, go in condition tab.
It's not nothing.
Now see in outlet. Now you have to define any two variables. For example, in a vapor phase of out, you just click type 0.5. Do not just close this. Close this. Just Type there. Direct 0.5.
Yes, sir.
Okay, and pressure and temp and okay, pressure 100 below one below scale. Okay, 100. Enter. Now it is converged.
67.
Now
Yes, sir.
67.03 temperature is calculated that that is 0.5. 50% flashes could be generated at this temperature at this pressure. Now
Yes.
you can uncheck or delete any value. For example, 0.5 vapor phase fraction. You just delete this
Okay.
and then delete, and then you just type temperature 67.03. Temperature 67.03. Enter. So you see again calculated almost same figure 0.5.
099.
Okay, now you have given temperature and pressure, so vapor and heat is calculated. Now instead of
Okay.
pressure, you just delete the pressure.
Okay.
Enter, enter, delete. Okay, empty, and you just click on vapor phase 0.5. Enter. So you notice
It's
get
already.
again 100 calculate. So
Yes.
this
Yes.
tutorial. Okay, thank you. I hope you understood. Any
Yes, sir.
any anyone else? Now, just before leaving, because it's 1 p.m. here, 1 a.m. Sorry, here. Now, I want to. I hope you all are watching my screen again. Now, one very short description about the unit sets. When you first install your HYSYS, by default, it is here. You can see unit sets are on the main screen on home on the first, second menu. This is units. Now, one thing is unit sets, and selected unit set is highlighted in the upper box. If I am drop downing this box, so I can see I have a field, SI, euro. These three things you already see in your menus, and safety EN. Then few units you are watching on my screen like new user one, new user two, and so on, or some other names. These are the my created unit sets. What you do sometime by default, usually SI systems are selected. SI system means temperature in degree C, and pressure is in a kilopascal, and molar flow rate is in a kilogram mole. So some SI units are already set for all variables. For example, you do not want to put degree centigrade again and again. You want to put in directly in a degree F. For example, I can put degree F information here as well. For example, my information is 45 degree F, so I can change the unit from here as well. But it will convert it in degree C because selected unit is degree C, so it will always shown by degree C. Now, this is not recommended, or this is not suit me because I always want to see in degree F for some simulations. So I just click on the unit sets. Now here you will see that unit sets, here you will see that a new user set will be defined. Okay, so you just giving your unit sets name. By default, it is new user. Then 1, 2, 3 accordingly number will be add up. So you just click any particular one variable which is problematic to you because they are cloned from some standard units. For example, they are cloned from SI. All the variables are mentioned here, physical quantities are here, and their appropriate units which is coming from the basic unit SI. But I want to change the temperature. I want to highlight temperature always in the degree F. So I go in a T. These are the alphabetically ordered unit physical quantities. T, temperature. Now you see degree C. You just change here and degree F. Now new user set 2. When I select this unit set, then I will show. I will see always temperature in degree F. So nothing more would be done. Just click OK, and by default it is selected. But if it's not, you have to select this from here, and now you will see that default unit of temperature always visible in a degree F. So if you are not watching your appropriate units, you just try this. One thing is that you cannot change the primary unit sets. For example, if I say SI units, when I click any standard units sets here, you will notice that their variables are now in black text rather than blue. Now you can not change these variables, but you can copy. For example, my most of the units are SI units, but my few variables are of my own interest. So you can copy from SI or field. Field is the oil and gas sector. So many things are in like temperature and degree F, pound, foot pound systems, yeah, or Euro SI. So whatsoever you want to copy, you copy it. You will notice one another unit set is created by new username 3. Now you notice that units are in a blue text. Now you can change any unit, and then you can have the flavor of that particular variable in your own unit. So I hope you got the idea how you can set the units, and then you select the appropriate unit set from here. Okay, now the second tutorial which I shared already with you, you try at your free time. Steam tables, this is also important. This tutorial is already given to you on that how steam tables are being generated in HYSYS because steam tables are very much important, and in industries, steam tables and their relevant properties are readily being utilized. So this menu, this tutorial, we will work on this tutorial again, but so in tomorrow. But you try at your best and you generate your own steam tables like this. So I hope you will try this, and you will try more and more with me, and we will go through this thermodynamics tape in upcoming 2 session as well, and then we will move to the separations. Okay.
Okay, sir.
Okay. Now I'm
Great.
closing the